In this video, we are going to talk about the parts of an atom. The first thing we're going to do is we're going to define an atom, and then we're going to talk about what the parts of the atom are. Then we're going to talk about how you determine or count the parts of an atom, and then we're going to talk about isotopes. So let's start with what is an atom. An atom is defined as the smallest unit of matter. Now, you might be thinking to yourself that you know that there are smaller units. Inside of an atom, there are smaller pieces. But an atom is the smallest unit of matter that still retains or that still acts like whatever type of matter it is. So it still retains the properties of whatever element it is. So for example, we have graphite. Graphite is the stuff that's in your pencil that we call pencil lead. It's not actually lead. If you were to look at it up close, you would realize it's made of a whole bunch of carbon atoms that are all stuck together, and that if you were to divide it down into the smallest piece would be an atom. And that's a carbon atom. And that atom, as long as I don't divide it, which I could, still acts like the carbon in that graphite. It still retains the properties of carbon because it's still considered a carbon atom. Okay, so now let's talk about what are the parts of an atom. Because atoms have parts, they can actually be divided. Remember, Dalton knew that atoms of different elements were different from each other, but he also thought that atoms were indivisible or indestructible, which we know isn't true, that they're actually subatomic particles that were discovered by Rutherford and Thomson and Chadwick and other scientists. So here's a model of a lithium atom. We now know that the nucleus of an atom is made of both protons and neutrons. Protons are positively charged and the neutrons are negatively charged, and that they all stick together to make the nucleus. And we know that electrons orbit around the nucleus and are not stuck to the nucleus. Let's summarize the parts in a table. So the subatomic particles, by the way, subatomic particles, subatomic, sub means within, and atomic means the atom, right? So subatomic means within the atom. The particle, proton, has the symbol P+, like you see right here. A neutron has the symbol N0, and an electron has the symbol E-. The location of protons and neutrons are the nucleus. They actually make up the nucleus. It's not like there's a little case around the nucleus and the protons and neutrons are packed inside of there. In fact, the protons and the neutrons stick together to make the nucleus. And electrons are orbiting the nucleus. So they're outside of the nucleus. All right, the charge. We're going to talk relative charge, and what I mean by that is I'm not going to give you the Coulombic charge, the actual charge. I'm going to give you the charge relative to one another. So we're going to say that protons have a +1 charge, neutrons are neutral, they have no charge, and electrons have a -1 charge, meaning they have exactly the opposite charge of a proton. Okay, and as far as mass is concerned, again, we're not talking mass in grams, we're talking mass in atomic mass units. So a proton weighs 1 atomic mass unit. A neutron also weighs 1 atomic mass unit. And a electron weighs 1/1840th of an atomic mass unit. So what that means is if I have 1,840 electrons all clumped together, they would weigh exactly the same as a proton or a neutron. All right. So let's go down to how do you count the parts of an atom? So to do that, you're going to need some information, and a lot of that information you can actually get from this thing. This is called your periodic table. The periodic table is a very useful tool, and we're going to use it a lot in this class. But you'll notice that on the periodic table, every element, for example, carbon, has a tile on the periodic table, and in that tile is a whole bunch of information. So let's look at this information and see if we can figure out what it all means. All right, so first things first, you have the element's name. And then you have the element symbol. I want to point out to you that the symbol, if it's one letter, it's uppercase. But if the symbol has more than one letter in it, like for example neon right here, the first letter is uppercase and the second letter is always lowercase. All right, the other things, the other features to the square on the periodic table are this whole number 6 above carbon is called its atomic number. The atomic number is actually equal to the number of protons. So if I want to know how many protons are in a carbon atom, I just need to look at its number on the periodic table. And you'll notice that they're in order of atomic number. So boron is 5, carbon is 6, nitrogen is 7, etc. They go in order. You should also know that the atomic number is actually like a fingerprint. It's what identifies the atom. So if I have an atom and it has 6 protons in its nucleus, it's a carbon atom. If I have an atom that has 7 protons in its nucleus, then I have a nitrogen atom, etc. Okay, and then we also have down here, we have this. This is called the atomic mass. And sometimes the atomic mass is actually written in a corner, but in this case it's below the symbol. The atomic mass, I want you to notice, is a decimal number, right? It's not a whole number. If I wanted to, I could round it to get what we call, so if I round it to a whole number, I get the mass number. And the mass number is an important number because the mass number is equal to the number of protons plus the number of neutrons in an average carbon atom. But as it stands, that number is a decimal number, the atomic mass, because it's actually the average mass of all the isotopes of that particular atom. And we'll talk about what an isotope is here in a second. For now, you need to know how to round that number to a whole number to get a mass number so we can count the parts. So let's count the parts. In a carbon atom, the number of protons is going to be equal to the atomic number, which happens to be 6 for carbon. The number of electrons in a neutral carbon atom, and we're going to assume all atoms are neutral at this point, is going to be equal to the number of protons. Therefore, in a carbon atom, it's equal to 6. Now, the number of neutrons is going to be equal to the mass number minus the number of protons, just like I told you kind of right here. So that means that if our mass number is 12, right, we have to round this to a whole number, and we subtract the number of protons, we're going to end up with 6 neutrons. So this particular carbon atom has 6 protons, 6 neutrons, and 6 electrons. Let's do another example. Let's pick something off of the periodic table. So let's pick something like lithium. All right. Lithium. Lithium's number of protons is going to be equal to its atomic number. So the number of protons will be 3. The number of electrons is equal to the number of protons, so 3. And the number of neutrons is going to be equal to the mass number, which in this case is 7, because its atomic mass rounds to 7, minus the number of protons is 4. So it has 4 neutrons, 3 protons, and 3 electrons. All right, so let's move our discussion to what an isotope is. So an isotope, remember back here I told you that an atomic mass is an average mass, so this number, that decimal number, is an average mass of all the isotopes of that particular element. So what the heck is an isotope? To explain an isotope, I'm going to talk about hydrogen. So Dalton said that all hydrogen atoms were identical to each other, but he was actually incorrect about that because he didn't know about subatomic particles. So here I have 3 isotopes of hydrogen. I have hydrogen 1, hydrogen 2, and hydrogen 3. So protium is called hydrogen 1, I have hydrogen 2, and I have hydrogen 3. Now this little shorthand notation that I just wrote, H-1, H-2, H-3, what this is telling me that these are all hydrogen atoms, but this is hydrogen with a mass of 1, hydrogen with a mass of 2, and hydrogen with a mass of 3. So how can they have 3 different masses? Well, let's talk about numbers of protons, neutrons, and electrons. So number of protons. Well, it's hydrogen, and hydrogen's 1 on your periodic table. So it has a mass, or rather, it has a number of protons equal to 1. So all of these have 1 proton. They're hydrogen. So here you can see the 1 proton in the nucleus. Number of electrons is going to be also 1 because they're all hydrogen and they all have the same number of electrons as they do protons. Now the number of neutrons is where things get tricky. See, hydrogen with a mass number of 1, remember how to figure out neutrons is you take the mass number and you subtract the atomic number and you get 0. So hydrogen 1 has 0 neutrons. Hydrogen 2, we're going to take the mass number of 2 and we're going to subtract the atomic number of 1 and we get 1 neutron. And then hydrogen 3 has a mass number of 3. You subtract the number of protons from that and you get a number of neutrons of 2. So hydrogen 1 has 1 proton, 1 electron, and 0 neutrons. Hydrogen 2 has 1 proton, 1 electron, and 1 neutron. And hydrogen 3 has, like this, 1 proton, 1 neutron, 1 electron, and 2 neutrons. So what makes these all different from each other is their number of neutrons. So the definition of an isotope. Isotopes are atoms of the same element that have varying numbers of neutron or varying masses. Because remember, the neutrons add mass but no charge to the nucleus. So what we're saying here is that all of these are hydrogen, right? Because they're all the same element, right? I wrote up here same element because they have the same atomic number. Because they all have the same number of protons, right? All these hydrogens have 1 proton. What makes them different is that they have different numbers of neutrons. So these are called isotopes. And when you look at the atomic mass for hydrogen on your periodic table, you'll notice its atomic mass is 1.008 atomic mass units. It's a decimal number because it's an average mass of all of these 3 isotopes, considering which one is the most abundant. So if I were to round that to a mass number, I would get 1. And what that tells me is that hydrogen 1, this isotope, is the most common isotope. That means that most of the hydrogen that I will find in the world will be hydrogen with a mass of 1. All right, let's look at our periodic table and we'll talk about, let's see if I can find the periodic table. There we go. So we'll talk a little bit about how most of these masses on here, most of these elements have masses that are decimaled. So what that tells you is that most of these elements actually have more than 1 version or more than 1 isotope. So if I want to know the most common isotope of any of these elements, like for example, if I want to know the most common isotope of aluminum, what I'm going to do is I'm going to take that aluminum and I'm going to round its molar mass, its atomic mass, to a whole number. So if I round that to a whole number, what I get is aluminum 27. And that tells me that the most common isotope is aluminum with a mass of 27. There happens to be other aluminums that have different masses, but that's the most common. All right, that concludes our discussion on what an atom is, what its parts are, how you count the parts, and what an isotope is.